Hello students, welcome in my class. Now in this week you are having the first periodic test. So we have to revise the portion on that one. We are having the portion number system or real numbers and the polynomial. First we like to revise the number system. In this one you have got this one, we discuss about the Euclid Division Lemma. Just recalling Euclid Division Lemma, what is it? That Euclid Division Lemma, it is Euclid's Division Lemma. What is that one? If A and B be two or any two positive integer or positive integer you can say, that will 0 also included. And one thing remember, B should not be equal to 0. Then there exists a positive number by any two whole number Q and R, unique whole number, such that A equal to BQ plus R. In this form means actually that is what? A is divided by B, then Q you are getting the quotient, R is the remainder. So if R is the remainder, then R should be what? It must be greater than equal to 0. If it is R is 0, then you know that is completely divisible, means B becomes the factor of A. And most important, that must be less than the divisor. So this is known as the Euclid Division Lemma. Using this Euclid Division Lemma, we can find, you can apply various cases, that's one. So first of all, we will like to revise from there. What? Suppose any positive number A we are having. To prove that any positive odd integer is in the form of any 4m or 4m plus 1 and 4m plus 3, or 6m plus 1, 6m plus 3, 6m plus 5, like that one. So in this type of questions are also important. How can we prove that one? In one question if we want to take, just suppose one question you are having, prove that any positive odd integer are in the form of or is in the form of 4m plus 1 or 4m plus 3 for some integer or for some whole number, so that will be better, whole number m may be any whole number. So you have to prove any odd number. Odd number is what? When you divide by the 2, then what you will get? If you may get the remainder what? 0 or 1. If it is 0 means completely divisible, that is the even number. If the remainder is 1, then that is known as the odd number. So that is the basic concept of the odd number. Dividing by 2, if you have the 1 as the remainder, then you can say that is the odd number. So in this, how can you prove? For this any question you can get this type of things, odd or even if you have to prove. So what you can take, let A be any positive integer. So if you have to check odd or even, so by 2 you have to think, but here you have to prove by 4. 4m means dividing by 4. So when A is divided by 4, let m be the quotient and R be the remainder. That means if we divide A by 4, you are getting Q, M as the quotient and R is the remainder. So by Euclid Division Lemma, but from Euclid Division Lemma, we can say that A to B, BQ plus R, so 4M plus R, here R should be what? Greater than equal to 0, less than 4. Less than 4. That means you can say R equal to 0, 1, 2, 3, like this one. You are getting. So case wise, if you think R equal to 0, So it is coming a equal to 4m, that is 2 into 2m plus 0 हो गया, 4m plus 0, that is remainder 0, that is 2 into something plus remainder is 0, that means it is what? It is in the form of 2n form. That means we can say n equal to integer 2m, that is an integer, so you can say that is an even number. Similarly, case 2, if we think that is r equal to 1, then it will come a equal to 4m plus 1, that can be written as 2 into 2m plus 1, so you can say 2q plus 1, 2n plus 1, like that one. So 2 into some integer plus 1 and divided by 2, 1 is the remainder here. So you can say that is an odd number. So clearly odd number in the form of 4m plus 1. Similarly, third case, you are having two more cases. You are having the third case and r equal to 2. So a should be 4m plus 2. So clearly 2 you can get common. 2m plus 1. It is coming n, that is n equal to 2m plus 1, that is integer. So what you can get, that is an integer. So 2 into some integer it is coming. So it is what? It is even number. Similarly, last case you are having, that is when a r equal to 3, it is coming a equal to 4m plus 3, that can be written as 4m plus 3 is the form of 2, that is 2 plus 1. So you can get 2 common, that means 2n plus 1, where n is this one. So that is what? 1 is the remainder, so odd number it is. So from there you can conclude that any odd number in the form of 4m plus 3 or 4m plus 1. So therefore any odd number is in the form of 4m plus 1 or 4m plus 3. So in this way we can do. So any number if you have, then you can explain that one. So many questions you can get. In this way you have to explain, you have to get that one. Or using Euclid division, you can get the HCF also. With that some particular type of question also, that is very important. 1 marks or 2 marks you can get also. Suppose one question, if we revise, prove that any question you can say 15 to the power n, any number in the form of 15 to the power n cannot be ended with 0 for any n is the any whole number. 15 to the power n cannot be ended with 0. 6 to the power n cannot be ended with 0. 4 to the power n cannot be ended with 0. Same categories question. First of all, you have to think any number to be ended with 0 means what? Ended with 0 means it will be last digit. But ended with 0 means last digit will be 0. One digit will be 0. That means it will be divisible by 10. Divisible by 10. Any other things can be, but it must be divisible by 10. So must be divisible by 10 means 2 and 5 must be the factors of this number. So that's to be concluded. How can you prove that one? Any number to be ended with 0 means 2 and 5 are the prime factors of this one. So 2 and 5 are the prime factors. That one should be. So 15 to the power n, they go 2 and 5 are the prime factors or not. If it is having, it will be ended with 0. If it is not having, then it will not be. So 15 to the power n, if we do the prime factorization, so what we will get? 3 to the power n into 5 to the power n. Check. You are not having, that's in whole number now positive integer ही कर दो. 0 हो गया, तो भी it is not ended with 0. 3 to the power n into 5 to the power n. See, it will not be divisible by 2, or 2 is not the prime factor of this one. So clearly 2 is not a prime factor of 15 to the power n. 5 is a factor, but 2 is not a prime factor. Therefore, we can say 15 to the power n cannot be ended with 0. Like this one we are having. Okay. So next revision class also will go through that one. Some more we are having, that is the irrational number of that one. With this today I will give you one assignment, you will practice and then I will go ahead. Okay. Thank you.